Every telescope ever built, including the most powerful one humanity has ever launched, is pointed at the same thing: a bubble. A sphere of space 93 billion light-years across, centered on us, containing 2 trillion galaxies, held together by gravity and dark matter and the faint afterglow of an explosion that happened 13.8 billion years ago. And right now, at the edge of that bubble, something is happening that physics cannot look past. The universe is not ending there, the bubble is. Here's what that actually means. The co-moving distance from Earth to the edge of the observable universe is about 46.5 billion light-years in any direction. The observable universe is a sphere with a diameter of about 93 billion light-years. But that is not the universe. That is the universe we can see. The boundary exists not because space stops there, but because light from beyond that point hasn't had enough time to reach us since the Big Bang. It is not a wall, it is a horizon. And like every horizon, it moves with the observer, which means every point in the universe has its own observable bubble. A civilization on a galaxy 10 billion light-years from here has a completely different sphere of observable space, overlapping partially with ours, containing galaxies we will never see, looking out at an edge they can never cross either. There is no center. There is no edge. There are only horizons, stacked endlessly in every direction, each one absolute from inside and invisible from outside. But here is where it stops being abstract. Regions sufficiently distant from Earth are expanding away from it faster than the speed of light. Assuming dark energy remains constant, there is a future visibility limit beyond which objects will never enter our observable universe at any time in the future, because light emitted by objects outside that limit could never reach Earth. The universe isn't just big, it is actively sealing itself off. Galaxies at the edge of our observable sphere are accelerating away from us. The light they emit right now will never arrive. We are watching them for the last time without knowing it. Every second that passes, our observable universe shrinks, not in size, in content. The galaxies we can see today are the most we will ever see. From here, the observable universe only gets lonelier. So what's outside it? The honest answer is that physics currently cannot say. But the leading framework for what happened in the first fraction of a second after the Big Bang, called eternal inflation, carries a specific prediction. Eternal inflation produces a hypothetically infinite multiverse, in which the decay of a false vacuum in one region led to the inflationary expansion of our universe, while surrounding regions continue to expand and produce other universes inaccessibly distant from ours. On this model, our universe is a bubble, one of an uncountable number of bubbles, each expanding into an inflating substrate that has no edges and no center, each one internally consistent, each one permanently separated from every other by the expansion of the space between them. In 2018, Stephen Hawking and Thomas Hertog published a paper arguing that the multiverse should be finite rather than infinite, using the holographic principle to define a boundary from the timeless state of eternal inflation. Their final paper, completed weeks before Hawking died, was an attempt to make the multiverse testable, to find the signature of other bubbles imprinted on the cosmic microwave background, the faint thermal radiation left over from our Big Bang, still visible in every direction as a uniform glow at minus 270 degrees Celsius. We have mapped that glow in extraordinary detail. Estimates place the total volume of the universe at least 250 times the observable, or 7 trillion light-years across, minimum, from cosmic microwave background fluctuation statistics. And we have found anomalies in it, cold spots, alignments, patterns that some physicists believe could be the bruises left behind by a collision with another bubble universe billions of years ago. We don't know what's outside the observable universe, but we are looking at its edges every time we look at the sky. The glow of the Big Bang is the closest thing we have to a window, and some of the patterns in that window don't yet have an explanation. That's not a gap in knowledge, that's a door.